Chapter 6: Experimental Research. Experimental research is the most rigorous of all research methods, and effect the literature reveals that its use in LIS research studies. Causality. Causality suggests that a single event always leads to another single event. The relationship between phenomena of determining factors, which increase the probability of ascertained event causality, is essential to the proper testing of causal hypothesis or relationship, and is useful in designing research. The condition for causality. Causality concerns relationships where a change in one variable. There are three conditions for causality: covariation, temporal precedence, control for three variables. Controlling the variables. It is measuring extraneous variables and accounting for them statistically to remove their effects on other variables' data, along with independent and dependent variable data in regression analysis. Random assignment. It is a procedure used after the sample is selected but before the experimental treatment is applied. Involves randomly and comparison groups. Specific techniques used for random sample. The researcher may elect, for example, to draw names from a hat. Use a table of random numbers. Internal validity is crucial to the dependability of the results of an experiment, and it is closely related to replicability. Internal validity provides confidence that the observed effect on the dependent variables is actually due to the independent variables. Threats to external validity. The threats to external validity are basically interaction effects, including the experimental treatment and some other variable. Experimental design is the process of carrying out research in an objective and cut-through fashion so that precision is maximized and specific conclusions. True experimental design. The pre-test control group design. The Solomon for group design. The post-test only control design. Factorial design. The experiments and correlational studies. This type of research may well permit one to predict change in one variable based on knowledge about another variable about would not allow the establishment of a causal relationship between the variables. Difficulties to be avoided. Relying too wholly on a single experiment, using poorly designed or faulty data collection instruments, not identifying one of the variables that may affect the results, not choosing subjects that are as representative of the population, introducing experimental bias, introducing subjects bias, making the subject aware of the hypothesis being tested, using an insufficient number of subjects. Evaluating the experimental. There are several points that the research should consider. The experiment shall leave the ability to test a null hypothesis which suggests that there is no relationship between the variables being studied. Pre-experimental designs, which will be considered first. Arithos designs which not only lack random assignment but which have few observation points as well. Quasi-experimental designs are not as strong as those for true experiments, as they do not have randomly assigned treatments and comparisons groups. Comparisons must be made with non-equivalent group with the some subjects in one group prior to and after. Examples: BOD quasi-experimental designs. The equivalent time sample design. The pre-test post-test non-equivalent control group. The multiple time series design. Exposed fact designs represent a worker type of quasi-experimental design. They are designed to simulate real experimentation by using state group type comparison. Web-based experiments are becoming more common, especially in some of the soil science. This technique allows researchers